So let's move to the next question we have in this sequence. Now our next question is, when a 12 volt battery is connected across a unknown resistor. So what you have given? You have given a 12 volt battery, it means value of V equal to 12 volt. There is a current of 2.5 milliampere. So what is the value of current here? Current is denoted by I and the value of the current will be 2.5 milliampere. Find the value of resistance of the resistor. What you have to determine? You have to just determine the value of resistance in the circuit. So what is the unknown quantity here? Unknown quantity will be resistance. Now when V and I are given and you have to determine the value of R, you will just apply the Ohm's law we have. So applying Ohm's law here, we will get V equal to IR. So R will be equal to V upon I. Firstly, you can see that the voltage is in volts and current is in milliampere. So we have to convert it into the ampere. So it come out to be 2.5 into 10 raised to the power minus 3 ampere, because 1 milliampere is equal to 10 raised to the power minus 3 ampere. So it is equal to 12 upon 2.5 into 10 raised to the power minus 3. Now what I am doing, I am just solving this equation. So it came out to be 2.5 and point is to be shifted in the numerator side. It is equal to 12 into 4 zeros here upon 25. On solving this resistance, 25, it has to be multiplied by 400, because 25 into 4 will give you 100. So 12 into 4, 48. So resistance came out to be 4800 ohm. So this will be the value of resistance in this case we have. So just apply the Ohm's formula if any of the unknown quantity V, I and R are given. So the answer here will be 4800 ohm. So just copy this solution from here so we can proceed to our next part. Now next question in this sequence we have, a battery of 9 volt is connected in series with all these resistors. So first write the given conditions here. Given condition is battery is of 9 volt. Now you are provided with 5 resistors here. So the 5 resistors here can be written as R1 equal to 0.2 ohm, R2 equal to 0.3 ohm, R3 equal to 0.4 ohm, R4 equal to 0.5 ohm and R6 is equal to 12 ohm. These all resistances are connected in series combination. These are connected in series. So what is the formula for calculating the total resistance in series? In the series combination, the total resistance will be the sum of all individual resistances. So I must write here that Rs will be equal to R1 plus R2 plus R3 plus R4 plus R5. So it came out to be 0.3 plus 0.4, 0.5 plus 12. 2, 3, 4, 5, we have 0.2 also, so 0.2. So it came out to be 12 plus 0.2 plus 0.3, 0.5, 0.5 plus 0.5, 1.0, 1.0 plus 0.4 will give you 1.4. So it came out to be 13.4 ohm. So you can see here, this is the value of voltage we have, and here we have calculated the equivalent resistance. Now, what you have to find in the given question, you have to find the current that is flowing in the 12 ohm resistor. So what you have to determine? You have to just determine the value of current here. Now, again I, V and R will give you a relationship between Ohm's law. So I am applying Ohm's law here. So from Ohm's law, V equal to IR, and current will be calculated as a voltage upon R. Voltage here is 9 volt and the resistance here is 13.4. So point must be shifted here. What I am getting here? 2 5 are 10, 2 6 are 12 and 67 here. 9 upon 67 into 5. So it came out to be 45 upon 67. Is it all right? Now, on dividing this 45 and 67, it came out to be almost 0.6 ampere. So what is the value of current I am getting here? The value of the current that I am getting here will be 0.6 ampere. It is approximately equal to 0.6 ampere. So again, this is a question from your NCERT which is based on the Ohm's law again. So just copy this solution from here so we can proceed to our next problem. Now, the next question in this sequence will be how many 176 ohm resistors in parallel are required to carry a 5 ampere on a 220 volt line? So this is again a very interesting question. What you have to find? You have to find the number of resistors here. But firstly, what you are given, write the given conditions here. Given is 176 ohm resistors. So you are given the value of resistors. That is equal to 176 ohm is required to carry a 5 ampere. Value of the current is 5 ampere on a 220 volt line. It means V here is 220 volt. Now, what you have to determine? You have to just calculate the number of resistors required in this case. So, the number of resistors will be, you have to calculate. So firstly, these all resistors, it means the 176 resistors are connected in parallel. So I am assuming that let number of resistors be n, and the Rp that is in the parallel combination, it came out to be n upon 176. It means these are the number of resistance connected. So it may be 1 upon R1 plus 1 upon R2 plus 1 upon R3. So we have the n resistors and it came out to be Rp equal to n upon 176. Now, again this is a relationship between I, R and V. We will apply the same law that is known as the Ohm's law. So again from Ohm's law, what we are getting? We are getting V equal to IR. What is the value of voltage here? Voltage here is 220 volt. What is the value of current? The value of the current is 5 ampere. What is the value of Rp here? Rp here is n upon 176. Now, I can solve it like this. 220 upon 5 is equal to n upon 176. 5 1 are 5 and it is 44 here. Now, it is 220 upon 5. So, this is the value of RP we are providing here. This is actually our 1 upon RP, because in the parallel combination what we are getting here 1 upon RP. It is the value of 1 upon RP. So, if I have to substitute the value of RP here, it must be equal to 176 upon n. We have to just reverse the value. This is another important factor you have to learn, that you have to reverse the values here. So, it came out to be 176 upon n. It is 176 upon n here. Now, n must be equal to 176 upon 44 and it came out to be 4. So, how many resistors in parallel are required to get the current of 5 ampere? You are just required the 4 resistors. So, the answer is 4 resistors are required. And the value of n is 4 here. So, this is the solution for this problem, and you have to remember, when you are connecting the resistances in parallel, you have just reversed the value, because in series combination we are just getting the sum of resistances, but in parallel combination we are getting a inverse relation here. So, this is a solution for our this problem, and this is a very interesting question we are getting here. Now, let's move to the next question in this sequence we have. How you connect the 3 resistors, each of 6 ohm, that the combination has a 9 ohm resistance and the combination has 4 ohm resistance. Now, let's draw a diagram here for understanding this question. Now, how you connected the 3 resistors? You are provided with the 3 resistors and you have to do the connection. Now, how do you connect these resistances? Either in the series or in the parallel. You have only 2 alternatives here. So, we are provided with the 3 resistors here. R1 6 ohm, R2 6 ohm and R3 equal to 6 ohm. Now, make the combination like that. You will get the equivalent resistance in the first case, that is equal to 9 ohm. You have to obtain the equivalent resistance in the first case, that is equal to 9 ohm. Now, suppose I am connecting all these resistors in the series. So, it will give you 6 plus 6 plus 6, it came out to be 18 ohm. So, this is not a correct option. If I am going to connect all these resistors in parallel, I will get 1 upon 6, 1 upon 6, 1 upon 6. It came out to be 3 upon 6, that is give you 2 ohm. Again, our both conditions are not satisfied. So, what you have to do? You have to just make a mixed combination of the circuits here. Either 2 in series, 2 in parallel, or 1 in series and 1 in parallel. So, what I am doing here? I am just connecting the circuit in first part. I am taking 2 resistance in series and 1 in parallel. So, just connect the 2 resistance in series first and 1 in parallel. This is our circuit diagram. This is our 6 ohm, this is our 6 ohm and this is our 6 ohm, and we will mention the name of the resistance as R1, R2 and R3. Now, if I want to find the equivalent resistance of a circuit, what I have to do? I have to do RS plus this resistance in parallel. This resistance is in parallel. So, what I have to do? I am just adding the first two resistances because the series combination 6 plus 6 give you 12. It will be 12 ohm. Now, this part is in parallel with this part. So, the R equivalent came out to be 1 upon 12 plus 1 upon 6. This is equal to 12, 1 plus 2 here. So, this is our R equivalent dash. So, the R equivalent dash came out to be 12 upon 3, that is equal to 4 ohm. So, you are getting 4 ohm here. So, 4 ohm resistance will be came out only in the case when you connect 2 resistance in series and 1 in parallel. So, this must be our solution of the second part we are getting here. So, this is our second part that we are getting 4 ohm. Now, what do you want to obtain in the first part? We want to obtain 9 ohm in the first part. So, again we will use the same concept. First part is we want R equivalent equal to 9 ohm. So, I am connecting 2 resistance in parallel. 2 resistance in parallel and 1 in series. So, what will be the circuit diagram I am getting here? 2 resistance in parallel. This is a parallel combination and 1 in series. This is the diagram we are getting here. So, this is our 6 ohm, this is our 6 ohm and this is our 6 ohm. Now, again you want to determine the R equivalent. So, it is a parallel combination and the parallel combination will give you 1 upon 6 plus 1 upon 6, that is equal to 2 upon 6. It is actually 1 upon R equivalent and R equivalent came out to be 6 upon 2, that is equal to 3 ohm. Now, this 3 ohm is connected to that 6 ohm in parallel. So, I am getting to find out here R equivalent dash, that is equal to 6 ohm plus 3 ohm. And what we are getting here? We are getting 9 ohm. So, our first condition is satisfied here. We are getting R equivalent equal to 9 ohm. So, if you want to connect the resistors in this system, you have to connect 2 resistors in parallel first, then in series, and for the second case, you have to connect 2 resistance in series and 1 in parallel. This is again very interesting question. So, just copy it from here. So, this is a combination of the resistances we have seen here. This is a very important question again. So, we have discussed many NCERT problems today. I hope this topic has been clear to you. So, this lecture is over for today. We will deal with many more numericals in our next session. Thank you so much and have a nice day.